So I hope you agree that this is the 5th time we see the same problem, or at least the 4th. We agree? Okay. So I have to write solutions anyway, because I did not. Okay. So we're asked to find f prime of a. We have 2 options. One option is limit as age approaches 0 from f of a plus age minus f of a divided by age. And the other option is f prime of a limit as x approaches a from f of x minus f of a divided by x minus a. Please choose any of the methods you like. We want to work on the second one. Okay. We agree with the second one? Yes? Okay, very good. So let's do that. So one more time, the function is 1 minus x, 2x plus 4. Of course, x cannot be negative 2. Perfect. So you said f prime of a, which is limit. So if you start f prime of a without the limit, I can give full credit. And I saw several of you did not write the limit. Some of you dropped the limit operator somewhere in the middle, and all of a sudden there is a number in there. I can give credit for that. So please make a note of how we present. That's why I would like you to redo the problems we do in class several times so you understand step by step what you need to do. And put that cell phone away, please. Thank you. Okay? So as x approaches a from 1 minus, so we copy the function 1 minus x divided by 2x plus 4 minus 1 minus a over 2a plus 4 divided by x minus a. So far, so good? Okay, so next step, we have to find the least common denominator. The limit operator cannot be dropped. You only drop the limit operator at the very last step. If you drop it in the middle, I cannot give full credit because it makes no sense. If I don't see the equal symbol, I don't know what it means. If you just write something, I can't follow through your thoughts. You have to put the equal symbol so I know how you start and where you end. Okay? So the least common denominator is the product of these two. So this is 2x plus 4 and 2a plus 4. Of course, this one needs a 2a plus 4, and this one needs a 2x plus 4. At that part, I think we got almost everyone on track. Okay, now the next step is to distribute here. 2a to both terms. 2a minus 2xa. 4 to both terms. Plus 4 minus 4x. So far, so good? Yes, everyone? Is this okay? Okay, now I have 2x plus 4 to distribute here, but I have to take into account this symbol. So 1 distributed to these two with minus in front. Negative 2x minus 4. Negative 1 times negative a will be a multiplied by these two. So plus 2ax plus 4a. And look, I made it without having to write above. Okay, let's see what happens next. I didn't ask, but of course this must be 0 over 0, right? And what do you expect to get rid of? Of course, x minus a is the problem here. That creates 0 over 0. Perfect. So let's see what is left. The negative 2xa and the positive 2xa, they go away. The positive 4 with the negative 4 go away. So now what I see is negative 4x minus 2x, limit again, equal symbol, please, either 1 or 2, whatever you want. X approaches a. So we have negative 6x. But I also have positive 6a divided by 2x plus 4 times 2a plus 4. Of course, there is a parenthesis there. Okay. Multiplied by, and I flip now 1 over x minus a. Are you okay so far? Is this okay, everyone? Descending order. No negative leading coefficient. Always keep that in mind. Always simplify or factor. Those are key words in math. Okay, so let's go back. And now I have limit As x approaches a, I of course factor out negative 6, 2x plus 4, 2a plus 4, times 1 over x minus a. I can simplify without stating restrictions because I know x cannot be a. Only at this step, I can drop the limit operator. If you drop the limit operator on the way, I can't give full credit. It makes no sense. So please remember that. So now, negative 6 is at the top. X approaches a. So this becomes a. 2x plus 4, 2a plus 4 times 2a plus 4 is 2a plus 4 squared. Yes, you can simplify it a little bit, factor out a 4 from here. It's 2 squared. You can. I'm fine with that. Any questions on this? Any questions on this? Yes, please, Dylan, go ahead.
This,
Go ahead. Is it okay?
I guess. I had 6a minus 6x. I took out the 6, and I had 6 times a minus x.
You cannot simplify a minus x with x minus a. You have to have everything in descending order and no negative leading coefficient. You cannot simplify a minus x with x minus a.
Oh, yeah, makes sense. I know.
Is that clear? Everyone? This is for everyone. Descending order, no negative leading coefficient. Simplify and factor. 4 key words that you should always remember. A descending order, no negative leading coefficient, factor, and simplify. 4 key words so far. Yes. Or Craig. Yes. Raymond, you want to say something? Okay. Other questions here? Other questions? Yes. I'm sorry? Yeah, go ahead. It's gonna be posted. I'll post it at the end of the class. Everything is posted anyway. So, Ricky, do you still need time? It's okay. Because I like to go over it with you, so let's not waste the time. It's okay. Good. So let's take a look at the other one. And that we had f of x equals negative 5x squared plus 7x minus 5. Ready? Which of the two definitions we want to apply here? It doesn't matter to me. You choose. Maybe we should, if you struggle with the other one or with the same one, whatever, I'll show the one you like. I can show both. It doesn't matter to me. So which one? The same one or the first one? Okay. So then we have f prime of a. We have to write the definition we use. Limit as age approaches 0 from f of a plus age minus f of a divided by h. I have to show the definition, present the definition, write the definition, so anyone who reads my work will understand what I'm trying to do. Good. So then limit age approaches 0, negative 5a plus h squared plus 7a plus h minus 5, but plus 5x squared minus 7x and plus 5. Is that okay so far? Yes? Okay, so can anyone give us this? I should have said other than you. Okay, that's okay, thank you. Very good. A squared plus 2ah plus h squared plus 7a plus 7h minus 5. I should have gotten rid of that, the 5 and negative 5. So plus 5x squared minus 7x. I made an error. Sorry about that. This is a. We are talking about a, f prime of a. There is no x in the expression anywhere. It's all a. Negative 5 plus 5a squared minus 7a plus 5. And of course, now these two go away. I distribute negative 5, limit. Age approaches 0, negative 5a squared minus 10ah minus 5h squared plus 7h plus 5a squared over h. And of course, as we know from a long time ago, all terms with no, in this case, no age For the f prime of a, same thing. All terms without h must go away. And then finally, limit as h approaches 0. 1, 2, 3 terms. They all have h in common. Please do not simplify in a sum. Please do not simplify in here. That would be incorrect. Negative 10a minus 5h and plus 7. We simplify now the h as a factor only. And now this is the only time in the entire problem when I drop the limit operator because I say h approaches 0. And the answer is negative 10a plus 7. This is the only time. Yes, Chris, go ahead.
If we brought the negative out of the parentheses.
That's fine. I saw that. That's fine. You wrote negative in front and you have 10a minus 7 in parentheses. Perfect. Any questions on this? Any questions on this? Any questions? Okay, I would like to go over problem 9 from the previous test. So let's copy it. We have f of x equals x minus 1, x squared minus 3x plus 2. Now this is problem 9. For the test, you have the entire time, and we'll have to schedule probably the second test outside of class. Together here, but outside of class, maybe on a Saturday or something, because we have to make up a class. We'll see. But for now, we meet again here on Thursday from 2. If you'd like to start early, you can. So if you want to start early and come in early, you can do that if you'd like. But you have to let me know. Okay, so I'm given this function and I'm asked, does it have an asymptote of any kind? So I know it's a rational function. You may have vertical and you may have horizontal. Yes, please. Okay. Okay. So a rational function may have vertical asymptotes. It may have horizontal. If it doesn't have horizontal, it may have slant. We're going to talk about that in chapter 4. And what is the first thing that I need to do here? I'm looking at this function. What was the first thought? Because I need to find what? The domain. I need to find the domain. So very good. So if the numerator is x minus 1, the denominator, when I factor it, is? Very good. At this point, before I simplify, yes, Mark, any questions? Go ahead.
I was, yeah, trying to get it happen.
I don't want to stop everyone. I can't find one right away. I lied. Very good. So I cannot simplify a function before I write the corresponding restrictions. Only then I can simplify it. This function has 2 restrictions, right? One is x not equal or 2. Only now I'm allowed to simplify. And the simplified form is 1 over x minus 2. Everyone agrees with that? Okay. So now I cannot draw any conclusions at this point, but I know that I have to present limits for x equals 1, x equals 2, left and right. This is my next step. And I also have to find the limits when x approaches infinity and when x approaches negative infinity. These are my next tasks because this will give us, if the answer is a number, this will give us the horizontal asymptote. And this one, if it's what? What should I have here for x equals 1 or x equals 2 to be vertical asymptotes? At least one side should be infinity or negative infinity. If it's not, if I get 5 on this side and 5 on this side, is that a vertical asymptote? No. What is it then? Yes, because the function is still undefined there. Yes, Chris?
Can you just say the vertical asymptote or the horizontal is 0 because the bottom degree is higher?
You can, but I still have to show what I'm doing. But yes, you can, because you know from pre-calculus that when a degree is higher in the denominator than the numerator, the function is what I call type 2, so the horizontal asymptote 0. Yes, I agree with that. Very good. So next, so let's find this first. So limit Sx approaches infinity from 1 over x minus 2. How come that I don't go back to the original function? I already simplified it. I stated the restrictions. The new function is 1 over x minus 2. Now you can say, but 1 over x minus 2 does not have these two restrictions. True. But this is the simplified form of that. So the domain has to be this. Anything but 1 and 2. I can go back and put that back in, because that's the starting point. This is the function we analyzed. But right now, it turned into this. And why not? I'm going to use the easiest form. Good. So what is this limit? Obviously, it's 1 divided by infinity. When you divide a cake to infinite people, how many everyone will get? 0, indeed. The same thing when x approaches negative infinity. The answer will be 0. So then what do we conclude? That y equals 0 is, since we did not use the fact that x approaches infinity or negative infinity is at both sides. Furthermore, it's a rational function, so that's what happens with rational functions. Good. So now I have to continue with the limit. As x approaches 1 from the left, from 1 over x minus 2, and limit as x approaches 1 from the right of 1 over x minus 2. These are my next steps. For x equals 1, in other words. So what is this answer, and what is this answer? What do we get? Good. What do we get? Good. So what do we conclude? Is x equals 1 a vertical asymptote? Not vertical asymptote, but hole in the graph. Why is it a hole in the graph? Because we are graphing the original function that is undefined at 1. Okay, so finally we have limit of 1 over x minus 2 as x approaches 2 from the left, and limit of 1 over x minus 2 as x approaches 2 from the right. What do I write? 1 over 0, which I know it's either infinity, negative infinity, or d and e. Indeed, 1 over 0 in both cases. And now here I plug in 2 from the left, 1.9, and give me the answer. Very good. And here I plug in 2 from the right, 2.1. Very good. So what do I conclude about x equals 2? It must be a vertical asymptote because at least one left and right is infinite. Very good. Yes, please.
So if there's a factor in the numerator and the denominator that cancel out, is there still a chance that that factor would be a vertical asymptote?
No.
Okay.
Unless there is another one left over.
Okay.
So if you, for example, it's a very good question. If I have x minus 1 divided by x minus 1 squared, if this is my function, I simplify. 1x minus 1 is gone, but I still have an x minus 1 left. As long as there is a factor left in the denominator, that will be a vertical asymptote. Any factor from the denominator that cannot be simplified with a factor, similar factor from the top, would be a vertical asymptote. Is there an exception? Yes. To that, yes. Here's another situation. Let's say I have f of x, which is 1 over x squared plus 1. There is a factor in the denominator, but this factor will never be 0. So this function does not have a vertical asymptote at all. This function is defined everywhere. There is no real number that makes x squared plus 1 0. So there are exceptions, of course, to everything. Okay, now let me ask you, what would you like me to do? What other kind of problems that you would like to see again? Any problem? Oh, I don't want to forget. I also want to go back to the limits. So we are going to discuss these a little bit later in the next chapter. So you don't have to worry about these right now. Yes, you have to remember this one, please. And basically as sign limit, right? So all these quantities, we discussed this, all these quantities must be the same, so for the answer to be 1. The rest was done from this supplement. Do not worry about the greatest integer function. We can work on it, but it's very specific, very special. Okay. We did have similar examples with these. If you want, we can work on these again. These will come into play in the next when we discuss exponential functions in detail. But we did discuss, we have the basics of that. These again will come back. We'll come back to the limits of log functions. The inverse trig functions we did not get to yet. We will. The hyperbolic functions we have not discussed yet. So the rest will come up, but not yet. So is there anything from this document that you would like to review? Yes.
The limits at infinity.
Okay, you want to look at these two? Okay, that's fine. So let's look at those. So we have limit 2x squared minus 5 divided by x squared minus 2 as x approaches infinity. Okay, when we plug it in, what do we get? Awesome, indeed. So then I have limit as x approaches infinity. What is the degree of the top? Not to 2. So then I factor out. I cover the denominator because I don't care what the denominator has. You should not decide what to do with the numerator based on what the denominator has. I don't recommend that. So you'll factor out x squared. What do we have left? Over x squared. Very good. Awesome. What is the degree in the denominator? So I factor out x squared. What is left in parentheses? I will simplify these two. Where does this fraction go? Where does this fraction go? Only because x approaches infinity. Otherwise, it will not be 0, right? And then the answer is, only now I drop the limit operator. And the answer is 2. What do we conclude about this function? Y equals 2, horizontal asymptote. Since we have not used plus or minus infinity, I will say everywhere, both sides. Okay, let's look at the last one. Yes? Yes, please, Ricky.
Why is it infinity equals infinity?
This one?
Yeah.
Which of these two terms is the most powerful when x approaches infinity? This one, right?
Yeah.
And this approaches infinity. Which of these two terms is the most powerful at infinity? X squared, not the coefficient. I'm asking about the term, right? X squared. So when x approaches infinity, I get infinity. So this is an indeterminate case. Like 0 over 0, infinity over infinity, and infinity minus infinity. These are the 3 cases that we worked on. There are 4 more.
So we just look at the term that has the highest power.
Yes, because that is the one that gives the degree. So that's the most powerful.
And if it's negative x squared.
Then it's going to be negative infinity. But in this case, it doesn't make any difference. Infinity over infinity, or infinity over negative infinity, or negative infinity over infinity, or negative over negative, it doesn't make any difference. It's still infinity over infinity. Very good question. Thank you. Okay, so let's look at the other one. So limit as x approaches infinity from x minus the square root of x squared minus 4x. I believe we did this problem in class, but I think we should do it one more time. It's a good idea. So let's plug it in. What do we have? Infinity? Yes. No one can predict this. It's one of the indeterminate cases. We cannot draw a conclusion. So what do we need to do? Exactly, rationalize. Very good. By x plus the square root, x plus the square root, both have to be the same. What do we have at the top? So we have limit, x approaches infinity. Can anyone dictate the top and I will write the denominator?
Minus x.
If you did not say parentheses, then you distributed already. So if you say parentheses, then say parentheses and I put parentheses. Any questions? I know. A squared minus b squared. The first term squared minus second term squared.
Do you not put the x minus in front of the x squared? Like, wouldn't it be x minus x squared for the numerator?
So I have a minus b times a plus b, which is a squared minus b squared. This is x, and this one is the square root of x squared minus 4x. So when I square this, I get x squared minus, when I square this, minus in front, minus x squared plus 4x. Hold on 1 second. Is that clear?
Yeah, I understand how you got that. I just,
Oh.
when you put an x minus in front of x squared
The denominator.
This one
for the numerator.
here.
Yeah.
But I have a minus b. If I multiply by a minus b, I'll get a squared minus 2ab plus b squared, and I'll never get rid of the radical.
So the x minus just goes.
So it has to be, we're using this formula. A minus b times a plus b is a squared minus b squared. If I want to put plus on both, then I would have a squared minus or plus 2ab plus b squared, and I'll never get rid of the radical. We have to use the difference of squares. If this is a minus b, I must use a plus b. If I have a plus b, I must use a minus b. Because when I multiply these two, I want to get rid of the radical. If they both have plus or both have minus, I will never get rid of the radical because of the middle term.
I understand how you got the numerator. I was just wondering, like, the x minus first parentheses.
This one.
Yeah,
Yes.
where that goes.
This is the first term minus the second term. This is the first term, then minus
Oh, okay.
the second term. Okay. So then I need the first term,
Okay.
but plus, that's okay, but plus, but maybe somebody else has the same question. So plus the second term. Does it make sense?
Yeah.
Everyone? Okay, perfect. Yes, please. I'm sorry, Vanessa.
Wouldn't the denominator be x, the denominator of the new equation be x minus the square root of x squared times 4x?
But this is in the numerator. So if I say that I have $10 in my pocket, I mean 10 over 1, not 1 over 10. There is no denominator here. So
Yeah.
this must be at the top.
Yeah, I know, it's,
So the
that over
denominator
1.
is 1. So 1 times this must be this. Right?
yeah,
There is no denominator.
yeah, I know, it's.
So this is not 1 over. If there is no denominator, it's at the top. Right? You can put it over 1. So then when I multiply the denominators, I get this. Better?
Yeah.
Everyone? Okay. So we distributed. You either put parentheses x squared minus 4x, or you already distribute. These two go away. And we continue. Limit as x approaches infinity. The numerator is 4x. I continue with x plus. What do I do now under the square root? What do I factor out? X squared. Very good. Awesome. And then what is left? 4 over x. Very good. So now at this point, I should write one more step as 4x over x plus the square root of x squared and the square root of 1 minus 4 over x. At this point, I have to make the following argument. What does the square root of x squared equal to? You should say the absolute value. However, you're right, because x approaches infinity, you can replace that by positive x. So I will write this is x since x approaches infinity. So at this point, all I have to do is factor out x from these two quantities. This is one term and this is another. But I have to write one more step for everyone to see what we're doing here. So this is limit as x approaches infinity, 4x over x plus x, the square root of 1 minus 4 over x. Yes, please. Tiwa? Yes, it would have been yes. I would have written negative x if x would approach negative infinity. Correct. Yes, please, Dylan.
You'll be posting everything on Canvas, right?
Oh, yes, of course. Yes.
We have the x plus square root of x squared and then the 1 minus 4 over x. Before we had that in parentheses, 1 minus 4x, why is there the radical?
Say it again.
Like 1 minus 4x is, never mind, the whole thing's under.
Yes, this is a product. And I separated it because the square root of a product is a product of square roots. Yes, Ricky?
So if you think the square is going to form x squared, and the square cancels out, maybe it's just
Only if x approaches infinity. If x does not approach infinity, or I don't know, I have to write the absolute value.
to the absolute value.
The square root of x squared equals the absolute value of x. Because we don't know what x is. Timo?
So we put in a like this cancel the value.
I'm not canceling the radical. I'm saying the square root of x squared.
Yeah, no, I'm just saying you couldn't have canceled. You couldn't have canceled each other out. Like the square root and the radical.
The square root of x squared, you mean?
Yeah, I know, but couldn't do it in the step before that.
Here.
I would like
So the question is, why don't I write the square root of x squared minus the square root of 4x? No.
like, you see the x squared.
Let's talk about the step up.
You can't cancel them out with the square root and the radical.
Yes, I did.
I know, but could you do it that way instead?
Here's a question. Very good. Here's your question. If I want the square root of a squared times b, is this just ab? This is like a question is it 4 times 3 just the square root of 2 and 3? No. So you have to take the square root from a squared and take the square root from b. You cannot omit anything, right? Because this is basically a squared times b, everything to 1/2. So you have to raise a squared to 1/2 and b to 1/2. Better? So when I have the square root of x squared y squared, I don't write x y squared. I write x y, of course, with absolute value. Because I have to take the square root from this factor and take the square root from the second factor as well. It's like raising to a power. It's the same thing, right? 2 times x squared. Do I write just 4x? No, because I raised 2 to the second power and I raised x to the second power, and I have to write 4x squared. Okay, everything okay now? Everyone? Ricky? Okay. Can you see from there? You can't. So let's move the table a little bit. I'm sorry, I forgot. Always remind me, please. Okay. Good, so let's continue, and we will factor out x from these two terms. Let's do that. So limit, so I continue here. As x approaches infinity, 4x at the top, and x gets pulled out in the denominator. Can anyone tell us what to write in the denominator after I pull out x from the first term? Plus, what is left from the second term after I pull out this x? Very good. Okay, finally we are done, sort of, right? So there is one more step. So now I removed an x from the numerator and an x from the denominator because they can be 0. Look where x is going, so far away, away from 0. So now, only now I drop the limit operator. The numerator is 4 and the denominator is 2. So then this is 2, which means y equals 2 is a horizontal asymptote, but this time I have to write because I used the sign. Where did I use the sign? Right here. I used the sign of the infinity to change this into x and not negative x. So therefore, I have not checked what happens at negative infinity. I only checked what happened at positive infinity. Okay, anything else?
How is the denominator 2?
Okay, so when x approaches infinity, this approaches 0. 1 plus 1, 2. Everyone else? Everyone else? Okay. Is there any particular type of problem that you would say, if I see this on the test, I may not be sure, or I just simply want to see another? Any type of problem? Are we ready for this test? Are we ready for this test? Please review the problems we did in class. Say it again. I wrote 9 questions, but the limits are like 6 or 7. So maybe you have 9 questions. You have the entire time. And some extra time. Yes, please.
Actually, we don't get any equations done.
What would you put on the note card? There is no equation. What equation?
There is one equation that I don't know. So
Yeah.
it's that long one where like the upside down A. Yeah, that one delta.
Oh, yeah.
Yeah, that really long one. That really
I
long.
think it's the one.
Oh, you can use it in, you can just put the plain English. You don't have to use the symbol.
It's the equation.
That's number.
Just write it 5 times
Yeah.
between now and Thursday, and you'll have no difficulties with it. Trust me. Anything else?
So if there's weird symbols in there, you must just be right. Okay, cool.
Do we have to know the
Like-
definition of alcohol and that?
Yes, you have to know that. But you don't have to use the symbols. You don't have to use the symbols, but please, yes. We even had a quiz, yes.
Just to make sure, the videos that you post online are on Canvas, correct?
Well, everything is in there, including the lecture notes. I scan everything I write on and I post that. Yes, you go.
That was a question I was going to ask.
Yes, it's from this assignment for today. Okay, yes, I'm ready. Anything? Yes? Cosine x equals x cubed. Yeah, we did this problem together. You just have to show that there is a solution between 2 points. So you have cosine x minus x cubed equals 0. You denote this function by f of x. You say that the function is continuous everywhere. So that's the intermediate value theorem. Please do not forget the intermediate value theorem. Okay? So 7, you have to say that f is continuous everywhere as a difference of 2 continuous functions, as you know. And then with the graphing calculator, you will put in this function in y equals. Make sure your calculator is in radians. So you have cosine x and minus x cubed. And go to second and table, but I have to go to second and again, by default it changes. Okay, second and table. And as a reminder, please do not bring to the test any other calculator but from 81 till 86. If you have an 89, 91, 92, or anything else that I have no knowledge of, please do not bring it to the test. Okay, so I'm going to plug in some numbers, 0, 1, and that's good enough for me. So when x is 0, the continuous function is positive. When x is 1, that continuous function is negative. There must be a solution between those 2 points by the intermediate value theorem. So I will say f of 0 is positive. You don't even have to put the number in there. I don't care about the number. F of 1 is negative. So therefore, by IVT, from continuity from 1 and 2, there exists a C in the interval 0, comma 1, such that f of c is 0. You do not have to use any of the symbols. You'll say by IVT, I will find a number c in the interval 0, comma 1, such that f of c is 0. Yes, Ricky?
This is probably a follow-up to
Yes?
this problem.
Yes?
I was confused when it was 6.
Yes?
On
This is it. This is the problem. Just it's a different function. The exact same problem. We can put that one in too. I no longer have, can anyone give me that function so we can put it in? What was it?
2x cubed
2x cubed
minus 8x squared minus 7.
One more time, minus,
Minus 7.
what was the second term?
Oh.
Oh, I'm sorry. What is the second term?
8x squared.
8x squared.
8x squared.
Okay, and minus 7?
Yeah.
2x cubed minus 8x squared minus 7?
Yes.
Okay, so just like we just did with the other function, plug in some numbers. So go to second and table. I will plug in 0, 1. I'll plug in 2. I'll plug in 3. I'll go back to the other side, -1, -5, -4. And eventually I'll find, let's see what happens at 0. 0, 1, 2.
It's really
Minus
weird.
2.
Say it again. Did you determine the interval?
Negative 2.
-2?
It's between 4 and 5.
4 and 5? Okay, I was getting there. So
Oh.
4 and 5. Okay, so all you have to say is that between 4 and 5, there must be a solution because the function is continuous as a polynomial function. Negative at 4, positive at 5.
We just have to find
You just have to find the interval
where it's positive and negative, right?
because it's continuous. If a continuous function goes from negative to positive, it must pass through 0. There must be a solution. Yes, Ricky?
So what do you mean by state the theorem and its hypothesis?
Yes. Number 1, you have to state the theorem that says hypothesis number 1, the function has to be continuous. Hypothesis number 2, it must change sign. So these are the two parts, exactly what we just wrote here. Here they are. So in number 1, you have to explain why the function is continuous everywhere. And in number 2, you have to find the interval where it changes sign. These are the two parts. Yes, Jared?
What is the top line saying?
F is continuous as a difference of two continuous functions. So we know that a sum or a difference, product or ratio of two continuous functions is also continuous. Or you can say, in our case, in the second problem, you can say simply f is continuous as a polynomial function. In the one from the previous test. Anything else? Yes,
Can you go
please.
over
Mark?
her question like number 1?
Like number 1 from the test.
Yeah.
Can you watch the video from last time? We did that.
Yeah, that's-
Yes, please. Anything else? Or you can spend time with me after class, and I can show it to you again. Yes, Jared?
Number 8 from the test already, or did you do?
If we did it already, then I can spend some time with you after class. Did we
Number
do
8 is
it?
already done.
Yes, we did that. It was the problem we just finished at the beginning of the class
Okay.
by finding the equation.
Oh, okay.
But I'll be more than happy to sit down and work with you on that.